What are the formula for it? We have seen two cases on stopping side distance. That is a case related to braking efficiency, and second case is a case related to gradient. That is an upward gradient or a downward gradient. So let me write the formula for stopping side distance once again here. Stopping side distance is equal to V into T plus V square by 2GF, right? Now I'm going to discuss one more case here that is based on the type of road. Right? For example, if this is a single lane road, let me write the type of road here. Single lane, two-way movements. Right? That is the case here. Now there is one more case here. Two-lane, two-way movements. So as it is having two lanes, one lane or one movement will be in this direction, in this lane, and another movement will be in this direction, right? And there is one more case here. Let me write for you. This is a median here, and this is one lane, and this is another lane. So I write it as two lane. Here also it is two lane, but it is divided now. So I write it as divided. Two lane divided two-way movement. Right? So I've taken three cases here. Now, let me see what happens in these three cases. For example, if there is an obstruction here, okay? There is an obstruction here. So if there is an obstruction here, who should stop? Right? In order to avoid an accident here, what should happen? What should be done here? So in order to avoid an accident here, this vehicle need to stop, and whereas in order to avoid an accident here, even this vehicle need to stop. And for this vehicle to stop, it requires an SSD. And for this vehicle to stop, it requires an SSD. So in order to avoid an accident here, what is the side distance required? It is nothing but 2 times SSD. Right? So as it is having only a single lane, and in that single lane, vehicles are moving in both the directions. Vehicles are moving in both the directions. Right? So for a single lane, two-way movement, SSD is equal to 2 times SSD. Now there is one more change here. This is applicable only if both vehicles are moving with same speed. Because SSD is dependent on the speed of the vehicles. If both are traveling with the same speeds, V and V, means if they are traveling at design speed, then only this is applicable, right? Now, if one vehicle is traveling, first vehicle is traveling with the speed of V1 and second vehicle is traveling with the speed of say V2, then SSD is equal to, for the first vehicle to stop, it requires SSD 1, and for the second vehicle to stop, it requires SSD 2. If the speeds of the vehicles are different, right? So that's the first case here. First case. Now second case. For example, if there is an obstruction here, is it having any obstruction? No, right? If there is an obstruction here, only this vehicle need to stop and he requires SSD. And he can move because he is not having any obstruction, right? So in this case, SSD is equal to SSD only, because it is having two lanes, right? Similarly, if there is an obstruction here, only this vehicle will stop, right? It won't stop. So in this case also, SSD is equal to SSD only, right? So this is one more case here based on the type of road. So only for single lane two-way movement, stopping side distance is equal to 2 times stopping side distance. Now, this stopping side distance is influenced. This stopping side distance is influenced by what factors? The factors which are there on the question itself. What are which are the factors which are there in the formula itself? Now, what are the factors which are there in the formula? What are the elements which are there in the formula? Obviously, first one is design speed. That is V, right or not? Reaction time. That is T. And only F, coefficient of friction. Because this G is always constant, 9.81 meter per second square. Now, what happens if the design speed varies? So, as the design speed increases, the stopping side distance will, this stopping side distance is proportional to design speed, right? So, as the design speed increases, stopping side distance will increase, right? Similarly, reaction time. Again, this reaction time is directly proportional to stopping side distance. So, as the reaction time increases, the stopping side distance will increase because it is directly proportional, right? Similarly, if the coefficient of friction value increases, what happens? Again, as it is indirectly proportional, if the F value increases, the stopping side distance will decrease. As it is indirectly proportional. Now let us look into detail about this coefficient of friction and what are the factors which are affecting this coefficient of friction. So this friction value is again dependent on the type of surface. And we have different types of surfaces like bituminous surface, concrete surface, waterborne macadam, that is gravel surface, and earthen surface. Now, which material is having more coefficient of friction and which material is having less coefficient of friction? Obviously, earthen road will be having more friction, and the smoothest of all the road surfaces is cement concrete. That's why cement concrete roads, that's why in cement concrete roads, there will be an action of slipping due to less friction, right? So, based on type of surface, the coefficient of cement concrete road is very much lesser, and coefficient of cement concrete road is lesser. Coefficient of bituminous is more than cement concrete, and coefficient of waterborne macadam road is more than coefficient of bituminous road, and similarly coefficient of earthen road. So for earthen road, friction value, coefficient of friction is more, and for CC road, coefficient of friction is lesser. So that's the first element which is influencing this coefficient of friction. Now the second element is tire pressure. Tire pressure means the pressure inside the tire is called as tire pressure. Now what happens? If the tire pressure increases, as the tire pressure increases, the contact area will be lesser. contact area will be lesser, means it will be easy to move. Means it will be more easy to move. Why it is easy to move? Because friction is lesser. So as the tire pressure increases, coefficient of friction decreases, right? Second one is tire pressure. Third one is condition of pavement as well as tire. Both of them I'll explain in the same criteria. Okay. Now we have two conditions of pavement: dry condition and wet condition. Okay. Dry condition and wet condition. And we have two types of tires also: old tire, new tire. Old tire and new tire, right? Now, for example, if you take an old tire, what happens to old tire? Old tire is relatively flat because it has got worn out, right? Old tire can be an also called as worn out tire. So it has been running from many days, right? So it has got worn out shape, means more flat shape. So contact area will be more. Contact area will be more. As the contact area will be more, therefore friction will be more. Therefore friction will be more, right? Now it is exactly opposite for the wet pavement. It has got less contact area. So it has got less contact area. So the friction value will be lesser. Coefficient of friction is lesser, right? Similarly, new tire. Sorry, this is to be written here. New tire, contact area is lesser. So therefore friction will be lesser. Friction will be lesser. Now if you consider a wet pavement, means if there is any oil surface or if there is any water surface on the road, what happens? What happens? Now if there is any water surface, this is how the old tire will be, and actually the old tire should run on the pavement. But if there is any water surface on the road, then there will be a small layer which is formed, and that is called as water layer. Water layer. So there is a layer between old tire and the pavement. Old tire and the pavement. So your vehicle, your old tire will be moving on the tire surface. Sorry, moving on the water layer instead of pavement. So the friction will be lesser. Now the same is the opposite of new tire. What happens for a new tire? There will be threadings, there will be grooves for the friction, more friction, right? So this grooves will break the water layer. This is the water layers. So this will enable that this tire moves on the pavement, right? So friction will be more. So for an old pavement, for a dry pavement, and for a wet pavement, and for old tire and new tire, this is how the friction is going to vary. So these are the various cases in stopping side distance. That is cases related to braking efficiency, cases related to gradient, and cases related to type of road, and the various factors which are influencing this stopping side distance, right? So we can note it down for 2 minutes. So I hope you are done with the writing part. So let us solve some problems which are related to stopping side distance. So these problems are repeatedly asked in many of the government exams, including GATE. So there are lots and lots of varieties related to stopping side distance. Even in the last year, 2017, 2018 also, we have got a 2 marks problems related to the stopping side distance topic. It's a very, very, very easy to score 2 marks from this topic. Only one simple formula with a simple common sense how that formula has been derived or what is the logic behind that formula. That's it, right? So let us solve some problems now. So these are problems from the workbook. Workbook problems. First one. So we'll start with the basic problems, then we will be moving to difficult ones. Okay. First one. A vehicle is traveling at 80 kmph, had applied the brakes, and the vehicle traveled 76.5 meters before stopping. What is the coefficient of friction developed? Right? So first problem. So there is only one thing that is to be taken care here. The value what he has given, 76.5 meters, is what distance is it? Is it braking distance or is it stopping side distance? Just think what he has given. A vehicle is traveling at 80 kmph. So convert 80 kmph into meter per second, because the formula we have stopping side distance in terms of meter per second. So how to convert 80 into 5 by 18, which is nothing but 22.22 meter per second, right? So vehicle is traveling at 22.22 meter per second, had applied brakes, right? You stop the question. Next, vehicle travels 76.5 meters before stopping. So what is that 76.5 meters here? This 76.5 meters here is nothing but braking distance. So if you have got that, your problem is done, right? So we need to calculate coefficient of friction here. So braking distance is equal to V squared by 2GF, which is equal to 76.5 meters. So V design speed is given as 80 kmph, that is 22.22 meter per second. So 22.22 square into 2 into 9.81 into F is equal to 76.5 meters. So the only unknown here is F. So if you solve this, you would get F as 0.33, which is given in the option B, right? So that's the first problem. Right? Simple. Only thing is we need to know that 76.5 meters is a braking distance, right? Next one. Problem number 2. Please read the question once. If the design speed on a road is 60 kmph, so design speed is 60 kmph, and coefficient of friction is 0.35. Calculate the required stopping side distance for two-way traffic on a single lane road. So we need to calculate the stopping side distance for a two-way traffic on a single lane road. Yeah, so stopping side distance is equal to, we know the formula, V into T plus V square by 2GF, but the design speed is given in terms of kmph, so you need to convert into meter per second. So 60 into 5 by 18 into, has he given the reaction time here? No. So if not given, how much is to be taken? It is 2.5 seconds as per IRC, right? So 2.5 plus again 60 into 5 by 18 whole square divided by 2 into 9.81 into F is 0.35, which is already given. So only thing that is to be remembered here is reaction time of the driver is 2.5 seconds as per ARC, because he has not given it. So if you calculate this, it comes as how much? 82.1 meters. Right? Is that the answer? Is what he has asked us to calculate stopping side distance? Yes, he has asked us to calculate stopping side distance, but what is the twist here? We need to calculate the stopping side distance for a two-way traffic on a single lane road. We have seen the cases in the starting of the session, right? For a two-way traffic on a single lane road, stopping side distance is equal to 2 times the stopping side distance. So it is 2 times 82.1, that is 164.2 meters, which is given in option B. So that's the previous gate question, right? There are two important points. Two-way traffic on a single lane road, and reaction time is 2.5 seconds as per IRC. So if a problem is given, then you need to know, you need to clearly study that what type of road it is, whether it is a single lane two-way traffic, or whether it is a single lane one-way traffic, or whether it is a two-lane two-way traffic, right? That also matters in this question. So that is how we do this problem. Hope you have written it. Very easy one, right? Next one. Now this is a simple one. A test car is braked when traveling at standard speed, right? So there is a car and it has been braked when traveling at a standard speed. The deacceleration developed as measured by a deaccelerometer fitted on a car is 4.2 meter per second square. Obviously, if you apply a brake, the speed decreases, and similarly the acceleration of the vehicle also decreases, so they call it as deacceleration. So deacceleration is given in the question as 4.2 meter per second square, right? Find the skid resistance. Now if you see the options here, the skid resistance means he wants us to find the value of F, because all the options are given in terms of decimals, right? So he wants us to find the skid resistance, F, that is coefficient of friction. Now to know this, we need to do a very small derivation. Let us say this is your car. It is moving in this direction, and as it is, you have applied a brake, as it is said in the question also. So there will be a frictional force which is acting in this direction, right? So frictional force is equal to coefficient of friction into self-weight, because I've considered a plain road. Now what is force? What is force as per Newton's second law? Force is equal to ma. So m into a is equal to frictional force F into W. This m can be written as W by G into a is equal to F into W. So this F and F gets, sorry, this W and W gets cancelled. A is equal to F into G, but you have applied a brake, and the speed of the vehicle starts decreasing, so the acceleration also starts decreasing, so it is deacceleration. So I indicate it with minus. So deacceleration of the vehicle is equal to F into G. So here he has given that deacceleration is 4.2. So 4.2 is equal to deacceleration. Deacceleration is minus, right? So minus 4.2 is equal to minus coefficient of friction or skid resistance into G, that is 9.81. So the only unknown is F, and this minus gets cancelled. F is equal to 4.2 by 9.81. So if you calculate this, it comes as 0.43, right? Which is given in the option D. So that's a simple equation. You can remember it. A is equal to minus Fg, right? You can write it down. Yeah, I hope you are done with the writing part. Now let us solve some more problems related to the same stopping side distance. Now let us increase the difficulty. These are very simple problems what we have solved till now. Of course, these are also previous gate questions. Read the problem number 4 from workbook. A vehicle was stopped in 2 seconds by fully jamming the brakes, and the skid resistance measured was 9.8 meters. The coefficient of friction developed is dash. So it's a very good problem. You can do it without calculators. If you want, you can try. Now let me consider a figure. This is the road, and this is my vehicle, which is traveling with a design speed v, and it has been traveled. At some point of time, I got an obstruction, so I've applied a brake here, and I've stopped my vehicle at this particular point. So here the velocity is 0, and I have stopped my vehicle in just 2 seconds. And he has also given that the brakes, the skid resistance measured was 9.8 meters. And when does the vehicle skid? The vehicle will skid only after the application of brake. So that 9.8 meters is nothing but braking distance. That is the first thing that we need to know from this, because skid, a vehicle was stopped in 2 seconds, right? By fully jamming the brakes. If you fully jam the brake, it goes to skidding. So the skid resistance measured was 9.8 meters. So this 9.8 meters here is nothing but braking distance, which is v square by 2gf, which is v square by 2gf. Now, most of you or many of you will do a common mistake in the calculation of v. Let me write mistake people do. Mistake many of them do, because this I have seen in many of my direct sessions. This is the mistake that they do. What they do is, here consider the speed is v, and here they have considered the speed is 0. So we know that speed is equal to distance into time. So distance is 9.8. Sorry, speed is equal to distance by time. So distance is 9.8 meters. Time taken to travel the distance is 2 seconds. So they treat it as the speed is equal to 4.9 meter per second, but that is completely wrong. Completely wrong. If you see this formula, if you see this derivation, what is V? V is the design speed, or the speed of the vehicle which is there before application of the brake. At that application of brake, that is what V is. That is what V is. But what is this V? What you have got? This V is the average speed of the vehicle during braking distance. That's the average speed taken by the vehicle to travel from this point to this point. That is not what we want. We want the speed of the vehicle at this particular junction. That is before application of brake. That is what V is. Okay, so that's the common mistake most of you do, right? That's not what we should perform here. Now, how to calculate this? How to do this problem? So, I know the value of 9.8 meters, that is braking distance. I know the value of G. So, if I know the value of V, or if I get the value of V, I'll finish my problem because that is the unknown. So how to get the value of V? Now, for this problem, try to apply the basic equation, that is V is equal to U plus AT, because you know the final speed, you know the distance travel, and you know the time taken to travel, right? So that's a simple basic equation which all of us know. V equal to U plus AT. What is the final velocity here? Apply this equation for this space. What is the final velocity here? Final velocity is 0. What is the initial velocity here? Initial velocity is before application of brake. So it is V plus A into T. So from this, V is equal to minus A into T. Just now I have derived in the previous problem, after applying the brake, the acceleration is equal to minus Fg. So V is equal to A is minus Fg into T. Basically, V is equal to F into G into T. Now simply use the value of V here. So 9.8 meters is equal to V square, that is F square G square T square by 2GF. So 1G and 1F gets cancelled. So 9.8 is equal to F into G is 9.81, T is 2 seconds. So 2 square, that is 4 divided by 2. This 9.8 and this 2.8 gets cancelled. This 2 over here cancels with this 2. So F is equal to approximately 1 by 2, that is 0.5, which is given in the option A. Right? So that is how we solve this problem. Here we should learn two things here. This is the average speed, that is not the value of V, and to get the value of V, we should use basic laws of motion, that is V is equal to U plus AT, and I've used the derivation of the last problem using Newton's second law, that is A is equal to minus Fg, right? So please take down this problem. It's a very good problem. Yeah, so I hope you are done with this writing part. Now let us solve problem number 5 from the workbook. Again, this is a bit easier one. So a test car is moving at a speed of 72 kmph. So a car is moving at a speed of 72 kmph. (72 kmph) convert into meter per second. So 72 into 5 by 18 is 20 meter per second, right? Okay, it is moving on a road of having 2% upward gradient. So it is moving in an upward gradient. Gradient is 2%. Driver applied the brake when he sees an distraction. Okay, and if the reaction time of the driver is 1 0.5 seconds. So reaction time is given as 1.5 seconds. Assuming f is equal to 0.15, so the coefficient of longitudinal friction is given as 0.15. Calculate the distance traveled by the car before it stops. So he wants us to calculate stopping side distance. So v into t plus, now here you are having an upward gradient. So upward gradient means we should consider the effect of gradient f plus or minus n by 100. Now, as you are having an upward gradient, we should consider positive, right? Upward gradient is indicated with positive. So design speed is 20 meter per second. Reaction time is 1.5. So 20 square by 2 into 9.81 into f is given as 0.15 and 2%, that is 2 by 100. Everything is directly given. Only thing is you should consider the effect of upward gradient. Upward gradient is positive. That's it. Everything is directly given. So if you solve this, it comes as 150 meters, which is given in option C, right? It's a very simple and easy problem. I hope you are noted down this fifth problem. Yeah, next one. Sixth problem. It's a very good problem, and this is also a previous grade question. It is a bit new one, right? And recently they are asking this kind of problems. In one more exam also they have asked it in other fashion using the same methodology. Okay, let's see how to do this. A sign is required to put up asking the drivers to slow down to 30 kmph before entering to zone Y. Okay, so this is my zone Y. Okay. And all the vehicles who are traveling or who are entering into this zone Y should have a speed of 30 kmph. Right? Now, on this road, a vehicle requires 174 meters to slow down. 174 meters to slow down to 30 kmph. Okay, and this 174 meters includes distance travel during the reaction time of the driver also. Okay, so what is happening here is if you keep a signboard, the driver traveling on that particular road, for example, I have kept the signboard as here. This is my signboard location. What will I write? Speed limit 30 kmph. Yeah, speed limit is 30 kmph. So this is the signboard, and I'm coming from this direction. So first I need to see that signboard, then I need to react it, I need to apply my brake, I need to slow down my vehicle to 30 kmph before starting off zone Y. All these things should happen, and for all these things should happen, I require 174 meters to slow down to 30 kmph. That is what it means, right? Now, this signboard can be read by a 6x6 vision driver from a distance of 148 meters. So, for a 6x6 vision driver, that signboard can be read from a distance of 148 meters. Now the sign is placed at a distance of X meters from the start of zone Y. So this signboard is placed at a distance of X meters from the start of zone Y. So that is my X. Okay. So that even a 6x9 vision driver can slow down to 30 kmph before entering to zone Y. So even that 6x9 vision driver also need to slow down to 30 kmph. What is the minimum value of X? So at what distance you need to install this signboard so that even a 6x9 vision driver can enter this 30 kmph before starting off zone Y. Now, to solve this problem, you need to know what is this 6x6 vision and what is this 6x6 vision. If you know those terminology, you can solve it easily. Of course, it is very easy to understand. Generally, if the numerator and denominator are same, you can take that as a perfect vision person. Okay? So, a perfect vision person can see this signboard from a distance of 148 meters. Once again, I am saying, if the numerator and denominator are same, that is the vision of a good person, good eye person. So, for a perfect or for a normal person, can see from a distance of 148 meters. Okay. So if I am traveling in this car, I can see this distance from 148 meters. If I am a normal person, means if my vision is 6x6. A normal person means 6x6. 6x6. So if both the numerator and denominator are same, that is the vision of a normal person, right? Now, for a 6x9 vision, that means a defective person. What is that defect? Vision is 6x9. So if you see from this figure, 6 is for a normal person. 6 is a normal person. So if a normal person sees from 6 meters or sees from 9 meters, then a defective person can see that only from 6 meters. That is what it means. So from this logic, 6x9 of 148 is 6x9 of 48. Sorry. So this is 48, this is not 148, this is 48. 6x6 vision driver can see it from 48 meters. So 6x9 vision driver can see it from 6x9 into 48 is 32 meters. 6x9 into 48 is 32 meters. So if a normal person can see it from 48 meters, a respective person will be seeing it from only 32 meters. Only from 32 meters. So here now I can see, if this is my defective person, I can see this from 32 meters, right? And from this distance, I can see, once I have started seeing this board, I require 174 meters to slow down. After seeing this, I require 174 meters to slow down and to come at 30 kmph. So what is my value of X? X is equal to simply 174 minus 32 meters, which is nothing but 142 meters, right?